So hello and welcome everyone to the video. As the slide suggests, we will be looking at time and work as the topic. Now, time and work happens to be a simple topic, and the good part about it is you do get questions on the paper from time and work. That means expect about a 2 or a 3 questions coming from time and work on the paper itself. Okay. So the session will not be a too lengthy session. It will be a small session. But what we're going to do is look at primarily a couple of methods of doing these questions. So what we'll be looking at is the 2 ways of solving these questions. Presume total unit of work and then go down to the individual efficiencies, or the other way around, which is presume the individual efficiencies and go down to the total unit of work. Now what we're going to do on this session is I'm going to take the first couple of questions and apply both the things and show it to you as to how it goes. And from there on, I'll, as usual, give you time to do the questions. Okay. So let's move on and let's look at the first question. I'm going to do this question. It's a very simple question, but will help me to explain you what is the logic behind me saying those 2 methods. A can do a piece of work in 10 days, B can do it in 12 days, and C can do it in 15 days. Okay, so individually, A can complete the work in 10 days, B can do it in 12, and C can do it in 15. That's the value which is given to you. Now, in how many days A, B, and C can complete the job working together? Okay. Now, there's one way which is something that probably majority of these schools, that is the way you're being taught, which is take 1 as the total unit of work, and then a lot of you then say that A in 1 day will do 1/10 of the work, B in 1 day will do 1/12 of the work, and C in 1 day will do 1/15 of the work. So if all 3 of them are working together, what will you do? 1/10 plus 1/12 plus 1/15. And you would then go on to say that the LCM is 60. So you will multiply this by 6, 5, and 4. So what you will get over here is 15, which is 1/4. So effectively, what are we trying to say? We are saying that out of 1 unit, 1/4 unit is done in 1 day. Why am I saying 1 day? Because this is 1 day's work of A, this is 1 day's work of B, and this is 1 day's work of C. So all put together, they are doing 1/4 unit of work. And when the total unit of work was 1, if 1/4 unit of work is done in 1 day, then in 1 unit of work will be done in 4 days, right? That's a simple unitary maths, but that's something that I would want you to avoid as long as possible. Now, my point is, we need to question this part, which is, why are we taking 1 as the total unit of work? Can we take something else as the total unit of work? Yes, we can, right? So let me just show it to you as to, if I take 2 as the total unit of work, then what happens? If I take 2 as the total unit of work, then A in 10 days will do 2 units of work. So A in 1 day will do 2/10 units of work, isn't it? B in 12 days again does 2 units of work. In that case, it will become 2/12. And C in 15 days does 2 units of work. So C in 1 day will do 2/15 of the work. Now, when you add all these values, you will get 1 day's work for all of them: 2/10, 2/12, and 2/15. When you add all of this, it will become 2 into 1/4, which is 1/2. Now, what is the question now saying? It is saying half unit of work is done in 1 day. How many days it will take to finish off 2 units of work, right? So that will be nothing but 4 days. The point that I'm trying to drive home over here is, taking any number of units of work over here does not really make any difference to the total number of days in which the work can be completed, right? So whatever may be the case, whatever number you wish to take over here, you can take that as a total unit of work, okay? But can we be a little more intelligent and do something which will help us reduce a lot of our calculation? Now look at this. Over here also you had to take an LCM of 10, 12, and 15. Over here also you had to take an LCM of 10, 12, and 15. The only thing that I'm going to suggest is, rather than taking 1 or 2 as the total unit of work, can I take 60 as the total unit of work? And look at it, if I take 60 as the total unit of work, what happens? But first thing first, how am I taking 60? 60 is nothing but LCM of 10, 12, and 15. Okay, so if I take 10, 12, and 15, the LCM will be 60. Now A in 10 days does 60 units of work. So A in 1 day will do just 6 units of work. You don't have to deal with fractions at all over here, right? B in 12 days does 60 units of work. So B in 1 day will once again do how many units of work? 5 units of work. And C in 15 days does 60 units of work. So C in 1 day will do 4 units of work. All three of them working together, they'll finish 15 units in a day. To complete 60 units, how much time it will require? 60 by 15, which will be 4, right? So point that I'm trying to drive home is be intelligent while choosing this number. Can I then look at the question and take an appropriate number over here and then get down to the answer? But a word of caution for each one of you. Please do not sit in the paper and wonder what will be the correct total unit of work, because there is nothing called as correct total unit of work. I've shown you it works with 1, it works with 2, it works with 60, it works with a fractional number, it works with any number whatsoever you take. That is not going to be a problem for you, right? So please do not waste your time in terms of understanding what will be the perfect unit of work, because there's nothing called as perfect unit of work. Take something and just apply your unitary maths and you will be fine on these variety of questions, right? So let's move on to the next question. And on the next question, I'll try to teach you the second part of it, that you can do the reverse way. So as of now, what we have done on this is we had taken something as the total unit of work, and we then got down to the units of work done by A, B, and C. In the next screen, what I'm going to do is I'm going to presume something for A, B, and C, and then get down to the total unit of work. Let's see how that is to be done. That's your question number 2. Let's have a look at that. Now it says that A is twice as efficient as B, and B is twice as efficient as C. That means there is efficiency comparisons which is very clearly given to you, right? If together they can complete the work in 10 days, how many days will C alone take to complete the work? That's what the question is. Now A is twice as efficient as B, and B is twice as efficient as C. So if I take C as 1 unit, B is twice as efficient as C, so then B will do 2 units per day. And A is twice as efficient as B, that means A will do 4 units per day, right? Now understand one thing, what did I presume? I presumed that A is doing 1 unit per day, okay? That's what I presumed. Earlier, what did I presume? In the previous question, I presumed the total unit of work, and then I wanted to get down to these values accordingly. Right now, what am I doing? I'm presuming these quantities, and eventually I'll get down to the total unit of work. Now, what is the question saying? If together they can complete the job in 10 days. If together they can complete the job in 10 days, that means in one day they are doing 7 units, correct? Now, in one day, if they are doing 7 units, in 10 days, they will do 70 units, correct? So the total unit of work that I'm going to now presume will be 70. Now, please understand, you can't take 1, 2, and 4 over here and take 140 as the total unit of work, because in that case, you're presuming both the things, right? So either you presume the individual work done per unit of time, or you presume the total unit of work, whatever that is, but only one thing at a time and not both together, okay? So 70 units. So total unit of work now turns out to be 70. Now, how long will it take for C to do the work alone? C will just take 70 days, isn't it? Because C was doing 1 unit per day. So how much time it will take to finish off 70 units? It will take 70 days. The question was very simple, but the point that I'm trying to tell you is either you start with this or you start with the total unit of work. One of the things you will have to do and then move on. This is to avoid fractions. And in some of the questions, you will have to get down to the fractions, but that's something which is unavoidable, right? But that happens to with a very less number of questions. That's the whole point, right? So probably majority of your questions you can deal with only integers and can get down to your answers. Both the questions are very simple. So let's move on and look at question number 3 and onwards. Okay, I'll give you once again time to do question number 3. Just give me a second. Yeah, let's move on to question number 3. At this question for a minute. Not a very difficult question, last 30 seconds. Right. So let's have a look at this question. Not a very, very difficult one. So let's quickly get over this. A can do a piece of work in 20 days and B can do it in 25 days. So individual work done was given to me. Work is done how many days that is given to me. A and B start working together. B takes 2 days leave. Work was completed in how many days? Okay. Let me say that A is completing the work in 20 days and B is completing the work in 25 days. So if I look at these two numbers, I can very safely presume 100 is my total unit of work. Okay. So I'm going back to the first method that I was talking about. So 100 is the total unit of work. Then I can very safely say that A in one day will do 5 units. Not a problem for any one of us. 100 divided by 20 will give you 5. And B will do 4 units per day. B will do 4 units per day. Now, A and B start working together and B takes the leave for 2 days. Okay. So suppose the work was getting over in n number of days. Okay. So A would have worked for n days and B would have done work for n minus 2 days. Okay. Now work was completed in how many days? Now 5 units per day and work for n days. So what is the total amount of work done? 5n. What is the total amount of work done by B? 4 into n minus 2. This is the total work done by both of them put together, and that should be nothing but the total unit of work, which is 100. So can I then say 9n minus 8 is equal to 100? So 9n will turn out to be 108 and n will turn out to be equal to what? N will turn out to be 12. 12 into 9 is 108. So the work was done in 12 days. I hope all of us are clear with this. Not a very difficult question once again. Let's move on to the next one. I just take another minute. Last 15. Right. Again, not a very, very difficult question. So let's try this out. A can do a piece of work in 10 days and B can do it in 12 days. A can do a piece of work in 10 days and B can do it in 12 days. That's what the question is talking about. Now, A takes a leave on every alternate day and B takes a leave on every third day. Work was completed in how many days is what the question is, right? Now, 10, 12, I'll presume the total unit of work as 60 or 30, whatever you wish, you can take that. Let me take that as 30. Okay, that's a smaller number, so that helps. So let me take 30 as the total unit of work. So in 10 days, 30 units of work. So in one day, I will do 3 units of work over here. Okay, sorry. 30 is not the LCM of 10 and 12. So we will take 60 as the total unit of work. So I'll take 60 as the total unit of work. A will do how many units per day? A will do 6 units per day. And B will do how many units per day? 5 units per day. Okay. Now A takes a leave on every alternate day and B takes a leave on the third day. Work was complete on every third day. Work was completed in how many days? Okay. So I'm talking about A, I'm talking about B, the total work done on that particular day. And let's start with day number 1. Day number 1, A will be working and B will also be working. So the total work done on day number 1 will be 11. Day number 2, A will be on leave, B will be still working. So you will get 5 days over 5 units of work over there. Third day, A will come back to work, but B will not be working on that day. So you will get 6 units of work. Fourth day, A will not be working, but B will be working. So you'll get 5 units of work on the fourth day. On the fifth day, it will be 6 and 5 again because B is taking leave only on the third day. So third day, sixth day, and like that. So that will be 11 units. Sixth day, A will also leave, will be on leave, and B will also be on the leave. So you will get 0 number of. Now beyond this, what will happen is this pattern will start repeating once again. So if I look at it, how many units of work is completed in 6 days over here? 22, 27 and 38 units of work. So 38 units of work was done in first 6 days. 7th day, it will again be 11 units of work, isn't it? So 7th day, you will have 11 more units of work. So how many units of work is now over? 49 units of work is now over. On the 8th day, 5 more units of work will be over. So what will happen? 54 units of work, right? And on the 9th day, 6 more units of work will get over, which is 60 units will be over on the 9th day. So the work is getting completed in how many days? Work is getting completed in 9 days. Now, if they would have wanted to take it further, and probably, it does not end at 9 and it could have ended at somewhere else, and if the total unit of work would have been more than second multiple of 38, I would have directly taken 12 days or whatever may be that closest integral multiple that you would get over here. You will take that many number of days over here and then iterate the last set. Okay, so we do see a lot of questions in the paper wherein you have to do this kind of an iteration, and the only thing that I would suggest is please do not miss out on this day. Okay, don't take your cycle of 5 days and then go back to the first day again, right? The cycle is not of 5 days, but the cycle is of 6 days. Be very clear with that, right? So let me remove this and let's move on to the next one. Question number 5, another minute or take a minute and a half. If you think it is difficult, try it out. Class 20. Right, so let's have a look at this question. It says A, B, and C together can complete the job in 12 hours. All three start working together. A leaves the work after 3 days. B and C continue to work for X number of days. A completes the remaining work in 4 days. Given that A is half efficient as B and twice as efficient as C, then what is the value of X? Now, once again, the efficiencies are given to me. So rather than presuming total unit of work, I will go and start doing my question from presuming the efficiencies for A, B, and C. Okay. Now, A, B, and C. What does the statement say? Given that A is half efficient as B, so whatever value you will take, you will do the half of that, and twice as efficient as C. So this value should be twice of that. Okay. So if I take 2 over here, I'll get 1 over here and I'll get half over here. I wish to avoid the fractions. So instead of taking 2, let me take 4. So if I take 4 over here, I'll get 2 over here and I'll get 1 over here. You can check once again, given that A is half efficient as B, so A will be half of B, and B is twice as efficient of C. So C into 2 will give you the value of A. Then what is the value of X, right? Now A, B, and C together can complete the job in 12 hours. So if they are working together, they would have done 7 units per hour. So 7 into 12 should then become the total unit of work, which is nothing but 84 units. So 84 units is the total unit of work, right? All three start working together. A leaves the work after 3 days. That means, can I simply say that A, B, and C, all three of them were working for the first 3 days? So they would have completed how many units? 3 into 7, which is 21 units. After that, only B and C are working for X number of days. Only B and C are working. That means 5 into X will be the number of units of work done by both of them in X number of days. A completes the remaining work in 4 days. A comes back and complete the remaining work in 4 days. So in 4 days, A will now complete 8 units of work. Total unit of work now should be again 84. We have to simply get down to the value of X, which is not difficult. 21 plus 8 plus 5x should be equal to 84. That makes 5x is equal to 84 minus 29, which is nothing but 55. So 5x is equal to 55. X should be nothing but 11. So that will be your answer. Once again, not a difficult question at all. And trust me on this, about a 90% of the questions coming from time and work are very, very doable questions. You should not be leaving this topic and getting into the paper at all. You must look forward to the questions coming from time and work, right? Let's move on. Let's look at the next question. Yes. Again, 1 minute. Right. So let's have a look at this question. Question number 6. Now, it says that a group of 10 men and 10 women and 5 men decide to complete a work in 50 days. After 30 days, they had completed 40% of the work. After 30 days, they had completed 40% of the work. Given that a man is twice as efficient as, given that a woman is twice as efficient as men, how many more men must join the group in order to complete the work in 45 days? They are now not completing the work in 50 days. They are now completing the work in 45 days. Given that a woman is twice as efficient as a man. Okay. So men might be doing 1 unit per day. So women might be doing, in that case, will be doing 2 units per day. Right. So I'm once again, efficiencies of women and men are given to me. So I'm going to start with presuming the work done by men and women in a day. Okay. Now there are 10 women. So as a group, women will do 20 units and men will do 5 units. So as a group of men and women, total unit of work done in one day will be 25. Right. Now, after 30 days, they had completed 40% of the work. So in 30 days, they will do how many units of work? 25 into 30. And that's nothing but 40% of the total work. The total work now I'm presuming it to be X over here. Now, how many more men, remember, how many more men must join the group in order to complete the work in 45 days? So in 30 days, they would have finished 750 units of work, which is 0.4 of the total unit of work. Correct? Now, if I take 750 by 0.4, what will I get? I will get the total unit of work. The leftover work is 60% of this. So can I simply say 0.6 into 750 divided by 0.4 is the pending work. And that should be done by 10 women over here and certain number of men. So let me now take the number of men as X. So a woman was doing 2 units per day. So 10 women will complete 20 units every day. Plus, I don't know how many total men are working now. So I'm going to take X number of men into, this will be the work done as a group by these people. And now 15 more days, you will have to finish off the rest of the work. So you will multiply it by 15. When we try to solve this, this will turn out to be 1550. So what will we get? 6 into 50 divided by 4 should be equal to 20 plus x. That's the value. So 2 2s are 4, 2 3s are 6, and 25. So what are we getting? X is equal to 75 minus 20, which is 55. Now remember, X was the group of men, right? So now the group of men which will be working will be having 55 men. How many more men have joined? 50 more men have joined. So the answer to this question will be 50 and not 55. Please be very careful. Don't mark 55 as your answer, right? Let's move on to the next one. This a question coming from one of your mock papers. Please try this out. Take about a 1.5 minute. Last 40 seconds. Right. So let's try and solve this question. Now, this question says that A and B can complete a piece of work in 40 days and 60 days. I know the work will be completed by them in 40 days and 60 days. Can I look at these two numbers and presume something as the total unit of work? Let me take 120 as the total unit of work. Right. Now, if 120 is the total unit of work, then A will finish 3 units per day and B will finish 2 units per day. Right. Let's go further. They started working together and after 12 days, A left. That means for the first 12 days, both of them were working together. So 12 into 5, they were doing 5 units together per day, right? So they would have finished 60 units. So the leftover work will be 60 units. Now let's go further. Now B is joined by C, who is half efficient as B. Now C is half efficient as B. That means B was doing 2 units per day. So C will be doing only 1 unit per day. Now B is joined by C, who is half efficient as B. Now B keeps doubling his efficiency every day from the next day of A's departure. That means from the 13th day onwards, B is doubling his efficiency and is working along with C, right? In how many days does the work gets completed? Okay. Now 13th day you are looking at, and 13th day B would have doubled his efficiency. So B would have worked for 4 units and A would have worked for just 1 unit. So the total 5 more units are over. Now remember, 60 units were over previously itself in the first 12 days. So the leftover work was only 60 units. So I need to stop when the work done is 60 or is getting more than 60. So at exactly 60, I'll have to stop. So 14th day, what will be the work done? B is doubling the efficiency, remember. So B is now working 8 units per day and C will be doing 1 unit. So total of 9 units. Once again, I'm just getting a sum of 14. So the sum over here, total, the leftover value was 60. So I'm still way short. Let's look at the 15th day. It will be doing 16 units and this will be doing 1. So 17 units. So 17 plus 9 will then turn out to be 26, 31. I'm still short. And 29 was the leftover number of units of work. Okay. So 16th day, B will be working 32 and 1. So on 16th day, 33 units will get over. But the problem is the leftover work after this work, because this work was how many units? 17 plus 26, 31, right? The leftover work was only 29 units, isn't it? Because 31 units was over till 15th day. Now on the 16th day, 33 units can be done. So 33 units in one day. So 1 unit will be in 1 by 33 of the day. And 29 units was left over. So 29 by 33 days it will take to finish off 29 units at that pace, right? So the work will get over in 15 days, 1529 by 33 days, right? So the answer will be this. Do not look at the options, and if the options are looking weird like the one which is there on the screen at this point in time, don't think about leaving the question. Doesn't really make any sense. Read the question and then try and understand as to what the question is all about, rather than just looking at the options and presuming something about the question. Please don't do that, right? Let's move on to the next one. This another minute. Last 15. So again, not a very difficult question. Let's try and work through this. A tank has 2 inlet pipes and 1 outlet pipe. Okay. Each inlet pipe can fill the tank in 10 hours individually. Okay. So the inlet pipe is filling the tank in 10 hours. The outlet pipe can remove the tank or empty the entire tank in 15 hours. So I look at 10 and 15 and I take 30 as my LCM, and I'll say 30 will be the total unit of work. That means the entire tank capacity will be of 30 units. Whatever may be the capacity, I'm calling that as 30 units. So I can get down to 1 unit will be how many liters kind of thing. But that is not required. I'm just saying for our perception to be pretty clear about this. So in 10 hours, it is doing 30 units. So in 1 hour, it will do 3 units. And the outlet pipe would remove 2 units every hour, right? Now go further. When the tank was half filled, already the tank is half filled. That means 15 units is already there in the tank. When the tank was half filled, all 3 pipes are opened simultaneously. How much time it will take to now fill 75% of the tank? Now remember, you need to fill only 75% of the tank. That means 50% was already there. That means the amount of water that will now get into this tank will be only 1/4, which is 25% of the total capacity, which is 30. So that should be the number of units that should now effectively get into this tank. Now remember, there were 2 inlet pipes. So the total work done by them will be 6 units. And the outlet pipe will remove 2 units. So per hour, the effective work done will be 4 units by all 3 pipes put together per hour. Okay. So 4 units per hour. How much time it will take to complete this many units? So 4 into the number of hours, which is, let's say, suppose n. So what are we doing? We are saying 30 divided by 16, right? So that should be the value of n. So let's just solve this. Okay, let's retry this question. A tank has 2 inlet pipes and 1 outlet pipe. Each inlet pipe can fill the tank in 10 hours. So the inlet pipe can fill the tank in 10 hours and the outlet pipe can fill the tank in 15 hours. Correct? So let me take 30 as the total unit of work. And if I take 30 as the total unit of work, the inlet pipe will be able to do 3 units per hour and the outlet pipe will be able to remove 2 units per hour. Right? Now, when the tank was half filled, that means 15 units are already there in this tank. Right? So that is something that you have to keep in mind when you proceed to the question. how much time it will take to now fill the tank with 75% of its capacity, right? So you need to now put in only 25% of the tank capacity, which is 1/4 of 30 that you need to now put in effectively, right? And this has to be done by 2 inlet pipes and 1 outlet pipes. So 2 inlet pipes will do 6 units and 1 outlet pipe will remove 2 units. So effective number of units left over will be 4 units per hour, right? So 4 into the number of hours should then be equal to 30 divided by 4. So the answer should be 30 by 16 as the number of hours, right? So 2 8s are 16, 15. So 8 1s are 8, or you can simply call 817 by 8 hours more from here on it will take to fill the tank, right? So let's move on to the next question. Question number 9, take again a 1 minute. Right, so let's have a look at this question. It says in a hostel mess, there's enough food to feed 60 students for 60 days. After 12 days, 10 students vacate the hostel. After 12 more days, 7 students rejoin the hostel. Food will now last for how many days in total, right? Now, let me say that one student is eating 1 unit of food per day. 1 unit of food per day. That means 60 students will eat 60 units of food every day. How many days was the provision for? 60. So can I say that the total amount of food available in the campus was 3,600 units, right? Now, after 12 days, so from day number 1 to day number 12, how many students were there in the campus? 60, right? After 12 days, 10 students vacated the hostel. That means from 13th and onwards, there will be only 50 students in the campus, right? And after 12 more days, so till from 13th to 24th, there will be only 50 people in the campus. And after that, 12 more days from there on, 7 more students have joined. So from 25th and onwards, there will be 57 people having the food in the mess, right? Now, food will last for a total of how many days? Now 60 into 60 was the total unit of food available. For the first 12 days, 60 people are eating the food. So they will eat 60 units per day. Multiply that by 12. That will then give you 720 units of food, right? So the leftover food will be what? Leftover food will be 2880. This will be the leftover food. Now, the next set of people who are consuming this food is 50 students. So 50 students for 12 days will again consume 600 units of food, right? So the leftover food will be 2280 for these 57 people. Now, from here on, let me say X number of days for which this food was lasting after this value, right? So 57 students will consume 57 units of food for X number of days should be equal to 2280, right? Now, what should be the value of X? 57 into 4 is 228, right? So X will be equal to 40. Remember, don't mark 40 as your answer. The answer will be 40 plus 24 days before that, which is 64 days. food will last for how many days in total? Food will last for 64 days in total, right? So the point that I'm trying to say is you don't really have to deal with fractions on time and work questions. Please take proper total units of work or total units of food in this particular case, or whatever that may be. Think about the total units and then try and do the question, or the other way around, that think about the efficiencies and then get down to the total unit of work. Whichever way, depending upon the question, we will have to select and move on. Okay, so that's about it from my side, guys. Stay tuned for further classes, and I hope all of you are a part of our 100 Days to CAT group. If not, please find the link for joining the group in the description of the video, and we will add you to the group shortly. Thank you.